Good morning students, I am Vetri Chervi from Vetri and Vetri NEET Chemistry. We are going to upload the video to Aiims 2019, topic is physical chemistry. Let us see the first question. If boiling point of water is 100 degrees centigrade, how much gram of sodium chloride is added in the 500 gram of water to increase its boiling point of water by approximately 1 degree centigrade? Kb value for water is equal to 0.52 Kelvin kilogram per mole. Okay, now let us write the what are the things given we can take it as a change in temperature. Now let me write the formula. Here formula is change in temperature. It is the boiling point is equal to I want of factor into Kb into molality. Now straight away of course we will substitute the data of course. Now change in temperature 100 degree and 1 degree increase. So delta TB is equal to 1 degree is equal to I is the want of factor, that is the number of ions it gives. Sodium chloride gives the made up of 2 ions. So here I is equal to 2. So 2 into Kb value is given, that is 0.52 and is corresponding unit into M is called molality. For molality, number of moles. What is number of mole is given by divided by molar mass of sodium chloride. To find out the sodium chloride, your sodium weight and your chlorine weight, you are having 58.5. This is molar mass of sodium chloride, 58.5 into weight of solvent. It is given in gram. So here it is into 1000. So this is the formula for getting the what is it called weight of your sodium chloride. Again I am repeating each one. Here increase in boiling point 1 degree centigrade. So difference mean whatever difference in centigrade is equal to Kelvin. So you need not worry about difference means whatever temperature unit the difference is same. So it is 1 degree is equal to I is the want of factor, that is sodium chloride is made up of 2 ions. So I is equal to 2. Kb value is given, W is the question. We have to calculate the weight of sodium chloride. So now here it is in the molarity divided by molar mass of your sodium chloride which dissolves in 500 gram of your water. Usually the solvent should be in the kilogram. Since it is given in the gram, I am taking as the 500 gram. To convert this a kilogram, it is gram to kilogram. It should be gram to kilogram divide by 1000. So that divide by 1000 is bringing here. So this is for your conversion of gram into kilogram. Now let us keep this W on one side. Bring the remaining on the next side. Bring the here 1 into, even it is a 1, you take it as account 58.5. Then only you will have that habit to do it. So 1 into 58.5 into 500 divided by. So W is here. Remaining part bring it on the opposite side in the denominator. We go in order, that is into 1000. Now you cancel this 1 by 2. Okay, now this one you have to on simplification 58.5 divided by 2 into 0.52. Let us first simplify with the 2 here. 2 and the 9 point here it is 25. Okay, again we will simplify with this 2. Okay, we will take it as a 28. Yes. This one here 2 into 0.5 is equal to, now let me write here, this is 29.25. After this you take it is divided by 2 into 0.5. So this become 1. So your answer is 29.25 divided by 1 is equal to your answer is 29.25. This is the way you can easily approach the answer here. Okay, now we are having nearing 29 is your 28. So our answer is 28. Again I am repeating, the formula is change in boiling point is equal to want of factor into the constant into the molality. So here the increasing temperature 1 degree and the water factor and the constant value given weight should be calculated. The 1000 for conversion of gram into kilogram, and it is the molar mass of sodium chloride. On simplification, you are getting the answer. Sum is very simple. Now let us go to the next question. At 298 Kelvin temperature, a hydrogen gas electrode is made by dipping in the platinum wire in a solution of hydrochloric acid of pH is equal to 10, and by passing the hydrogen gas around the platinum wire at the 1 atmospheric pressure, potential of electrode would be. Okay, now what are the things are given? Let us write here. Point number 1, that is pH of the acid is given as a 10, of course. Here what is the condition is they are giving the 298 Kelvin and 1 atmospheric pressure means standard condition. Okay, next one is what is the changes going on is they are not mentioning electrode potential, whether reduction and oxidation, it was not mentioned. But what is it? Hydrogen gases around the platinum. So you take the reaction in such a manner, hydrogen gas ionized to give us a He plus 2 electron. Here oxidation number is 0 to plus. So it is oxidation reaction we are taking, of course. Now for this reaction, this is the going on. For this reaction we will go for the Nernst equation. Now let us write the equation for it is E cell is equal to E naught cell minus 0.5059 divided by N log of cube. This is the formula. This is the common formula for the Nernst. Now let us see here what is our work is N have to calculate. What is N is the number of electrons. For that how many electrons are takes place? 2 electrons. So N we have to add the 2. And what about the Q is the product by reactant. Q is concentration of product by reactant. These two now let us substitute here. E cell is equal to E naught cell is the 0 for hydrogen minus 0.059 divided by number of electrons to log of. In this reaction, product is your 2H plus. So from that you have to write the hydrogen ion concentration. How we can find out the hydrogen ion concentration? pH is equal to 10 ml, that is equal to negative log of hydrogen ion concentration. So how we can do it? To remove the negative, here you have to put it. For this one small calculation I will do it here. That is negative log of hydrogen ion concentration is equal to 10. You have to remove this one. So log H plus equal to minus 10. You have to remove this one. What is it called? Log mean you have to write anti-log of minus 10. Anti-log mean you have to write to the power of 10. So your hydrogen ion concentration is 10 to the power of minus 10. So now that one you are adding here. Here this in the reaction product side it is hydrogen ion concentration. Product it is in the numerator. So 10 power minus 10. This is the concentration. Here of course it is written the stoichiometry is 2. That one you have to put it divided by. What is given is here it is hydrogen gas. Its concentration it should be taken as a unity 1. Now the main work is over. Let us come and do here remaining part of the work. Yes, 2 log of 10 power minus 10 into 2 minus 20. So I am writing here it is minus 20. Next we bring minus 0.059 divided by 2. This one you take it as minus 20 should bring here minus 20 then log 10. Log 10 value is equal to 1. So now this I can cancel it is you are getting 10. Minus into minus is become plus and 0.059 into 10 the decimal is moving here. So you are getting here 0.59 volt is the answer. Go and verify the answer you are getting the A. Okay, here what are the important points? First, take from the pH you have to calculate the hydrogen ion concentration as 10 power minus 10. The calculation I taught here. Next, this reaction should be very important. Based, if specifically they are asking oxidation reduction mean that you have to stick on. Otherwise, hydrogen gas is moving to the ions. Based on that, I have written this reaction. So here it is the, what is it called, quotient. Then equilibrium. What is the product divided by reactant? For follow the substitution, everything will be go smoothly. Let us go to the one more question. Now this question is belonging to chemical kinetics. The question is the decomposition of ammonia of the platinum surface is a zero order reaction. If the value of the rate constant is 2 into 10 power minus 4 mole per liter per second, the rate of appearance of nitrogen and hydrogen are respectively. Very easy and important, with it tricky also. First point is very important point you have to notice, decomposition of your ammonia. This is first point you have to note down. Now write down the equation of your decomposition of your ammonia. That one. Don't hurry up, balance the equation. 2 nitrogen and 6 hydrogen. So now your equation is balanced. Next point you have to note down is the reaction is called it as a zero order reaction. So what is the important knowledge is, for zero order reaction, what is given is, they give the rate constant is equal to 2 into 10 power minus 4, its corresponding unit is given, rate constant. What is the trick is, first trick you should know that decomposition reaction you should write carefully. Second trick is zero order reaction with the rate constant. So what is the relation with the rate and rate constant? I am going to write rate is equal to rate constant into concentration term to the power 0. What is the 0 mentioning? It is the order. Concentration to the power, this is become a 1. So because of this condition, what is the important point we are having is rate is equal to rate constant. So what I want to say is, this rate constant value you take it as a rate. So this is the next knowledge. Once it is ready made, you write the rate of the reaction, rate of the equation for this reaction. That is, I want to write the rate reaction. Let us write one by one. The rate of the reaction is equal to, here it is called it as a, what is rate of the reaction? You take the value also, that is 2 into 10 power minus 4 is equal to, we want a question is appearance of nitrogen and hydrogen. I want for nitrogen and hydrogen, so I am not taking this, I am going to the second part of the work. Formation of nitrogen. What is the formula? Is change in concentration of nitrogen by dt, which is equal to change in concentration of hydrogen by dt. Parallelly you write the stoichiometry is 1 by 3. So this is the formula we have to follow. Next cases they are asking the rate of appearance. So now this is called as a rate of appearance. In this case, this is called as a, these two are labeled as a rate of appearance. This knowledge is very important. Okay, now let us separate this relationship in two halves. In the case of nitrogen, now let me write the heading. For nitrogen, you take first half. 2 into 10 power minus 4 is equal to nitrogen formation. Okay, so exactly same answer. This is rate of appearance of nitrogen. This is the answer. In the case of your ammonia, what is this is? You now relationship this is 2 into rate of appearance of your one, correction children, it is hydrogen. Rate of appearance of hydrogen. Okay, now 2 into 10 power minus 4 is equal to, first we have taken this off, now we have to take these two part only. 2 into 10 power minus 4 is equal to 1 by 3. Your appearance of hydrogen with dt, this is only rate of appearance. So this is they are asking. So what we should do, this 3 should be bring it on the next side. So now 3 into 2, 6 into 10 power minus 4 is equal to rate of appearance of your, what is it called as a hydrogen. Now second answer is this is, first answer is this is. Let us go and see 2 and 6. Here it is 2 into 10 power minus 4, 6 into 10 power minus 4, and this is the answer. Okay children, even it is, what are the knowledge we have taken? First decomposition, the first knowledge. In the zero order reaction, both rate is equal to rate constant. This you are bringing. And the third point is here what rate reaction you are writing, and the what knowledge you should know is this part only, rate of appearance, that knowledge. So based on keeping the equation the two half, this is first half and the second half, you are getting the answer. Prepare well children. Thank you.